You know that humble, kidney-shaped cashew you love to snack on? Well, it has a secret. A wild, kind of dangerous, and honestly a fascinating story that takes it from a botanical oddity all the way to that delicious snack in your pantry. Let's dive in. So, let's just start with a simple question. When you picture a cashew tree, where's the nut? Is it tucked inside a big fruit, maybe like a peach pit? Or is it in a hard shell, like a walnut? Whatever you're imagining, yeah, it's probably wrong.
Because the first surprise on this journey is that the cashew isn't really what we think it is. Its beginnings are, well, they're just plain bizarre.
Okay, so meet the cashew apple. This is what the cashew actually hangs from. But here's the first really weird thing. It's not a true fruit. Botanists call it an accessory fruit. And get this, the way it grows is completely backwards from almost every fruit we know. The cashew seed, the part we eat, it grows first, and only after that seed is fully developed does this fleshy apple start to swell and ripen from the stem. Totally backwards.
So, just to be super clear, the part we call a nut is technically the seed. It's hiding inside that hard gray shell dangling from the bottom of the apple. Okay, so we've solved the first mystery, but this is where the story takes a pretty dangerous turn.
Because that innocent-looking shell, it's hiding a seriously powerful chemical defense. You can't just find one of these, crack it open, and eat it. In fact, you should never, ever try.
See, the shell is filled with this stuff called Cashew Nut Shell Liquid, or CNSL for short. It's a toxic, caustic, natural resin, and it's held inside this soft honeycomb structure within the shell. And we're not talking about a minor irritant here. This is a serious chemical hazard.
So just how potent is this stuff? Well, the main chemical in CNSL is something called anacardic acid, and it's in the exact same chemical family as urushiol. That's the compound that gives poison ivy its infamous blister-causing power. That's right, the cashew tree is literally a cousin of poison ivy, and it's packing the same chemical weapon.
And hey, don't just take my word for it. The Cargo Handbook, which is all about shipping hazardous materials, is crystal clear. It calls CNSL a strong irritant that causes blisters. This is exactly why manual shelling has historically been such a dangerous job, causing terrible chemical burns on workers' hands.
So if the raw nut is that toxic, how on earth do we eat them? Well, the answer is in this really remarkable industrial process, a journey of detoxification really, that's been engineered to make this hazardous seed safe and delicious.
The whole thing basically boils down to 4 key stages, and each one is designed to make that cashew safe to eat. You've got heat treatment to neutralize the poison, then the super tricky business of shelling, a very precise drying and humidifying cycle, and then finally peeling off that last little layer of skin.
Now that heat treatment part is absolutely critical for safety. Older methods like drum roasting were incredibly dangerous because they'd burn the shell and release all that toxic CNSL as fumes. But today, the industry standard is steam cooking. It uses high-pressure steam, which cleverly cooks the nut and turns the CNSL into this jelly-like fluid that stays inside the shell. It's way safer to handle and, importantly, prevents any of those toxic fumes.
So after steaming, you've got shelling. And this is a really delicate operation. You have to crack open that brittle, toxic shell with just enough force to open it, but not so much that you smash the valuable kernel inside. The shift from doing this by hand to using machines has been a huge leap forward, not just for getting more done, but, way more importantly, for protecting workers from even touching that CNSL.
Okay, so once the kernel is safely out of its shell and peeled, it's still not ready for the bag. Now comes what's really the art of grading, where every single cashew is sorted and classified to figure out its market value. This right here, this is the goal, a perfect whole kernel. This is the highest grade you can get, and it's what processors are aiming for through that whole difficult process. They've got that classic kidney shape, and they're going to get the highest price. But, of course, some kernels are going to break during shelling and peeling. It's just inevitable. These aren't thrown away, though. They're graded as splits or pieces. And while they're not as pretty as the whole ones, they are perfect for cooking, baking, or as ingredients in other foods. And there's even a special code for all of this. The grades you see on bulk packages follow a whole system. So WW means white holes, and that number tells you how many kernels you get in 1 pound. That means a WW180 is a bigger, more valuable cashew than a WW320. Other codes tell you if they're a little scorched or broken into pieces. It's a whole precise language just for cashew quality.
But the cashew's journey doesn't actually end with grading.
In fact, maybe the most exciting part of its story is happening right now, as the industry figures out how to transform its hazardous waste into really valuable resources.
This is where the story gets really, really clever, a true circular economy. Remember that toxic CNSL? It's now extracted and used to make things like biofuels and even brake linings. The shells themselves, they get burned for fuel or turned into something called biochar. That papery skin becomes compost, and any rejected kernels become animal feed. Literally nothing goes to waste.
And it's so important to remember, this innovation isn't just about the environment, it's about people. The same technologies that make this whole circular economy possible, like steam processing and mechanical shelling, are the exact same things making factories safer for workers, protecting them from those chemical hazards that were a huge problem for decades.
So the next time you eat a cashew, just remember its incredible journey. From a bizarre accessory fruit and a poisonous shell to a model of industrial ingenuity and sustainability. It kind of makes you wonder, if we can turn this one hazardous seed into such a force for good, what other challenges in our food system are just waiting for that same kind of transformation?